Kevin Emick. I'm the enterprise sales consultant for Tableau, and I am based in the great state of Michigan. All right. Wow, I brought my own contingency.
Absolutely.
Yeah, this is great. All right, so then I'll ask all my friends from Michigan. So somebody asks you where you live, what do you do? That's right, we pull out our hand and we point. Right? So I am from Little Lapeer, Michigan, all 8,000 of us, and I'm based down here in the thumb of Michigan. So, fantastic. Just a couple other fun facts about Michigan. We do have 4 out of the 5 Great Lakes touch our state. And while Minnesota claims to be the land of 10,000 lakes, according to Wikipedia, and we all know if it's on the internet, it's true, Michigan has over 11,000 lakes, inland lakes, that are 5 acres or greater. So, fantastic, right? We got a ton of water, and we take our map everywhere we go. Even if you're in the Upper Peninsula, right? We'll try to fill that in there too. So anyways, I'll be handling the first part of the session today, and then have my co-presenter introduce himself.
Yep, my name is Joe O'Brien. I am a customer consulting manager here with Tableau. I am also from the great state of Michigan, from about right there. Drawn to scale about 1/8 of an inch from Kevin. I'm originally from Flint, Michigan, one of the vacation capitals of the Midwest. Flintoid? All right, ready to go, brother? All right, we travel well here, both of us. So I have been in business intelligence and analytics for almost 20 years now, but only 2 with Tableau, so I'm still kind of a newbie. And I still run into a lot of the, my calculation doesn't work, or why isn't this number right? So I'm going to take probably the last third of the session, and I'm going to take you through some order of operations, but I'm also going to take you through some tips and tricks that I've learned from people like Kevin along the way that might help you on your journey as well. But Kevin's going to get us started and take us through probably the first 2/3 of the content, so take it away.
All right, thanks, Joe. All right, so imagine we, not all of us obviously can go at the same time, but a couple of us, we walk into a restaurant. We are greeted by the host staff. They take us to our table. They give us our menu and they say, oh, you know what, let me stop. Going too fast. I'm getting too excited here. What are we going to talk about? Oh my goodness. All right, we're going to explain the unexpected with Tableau's order of operations. We're going to take a look at a couple different things. One of life's orders, unstructured and then structured, and how they're on opposite ends of that spectrum. We're going to talk about you and introduce you to this Tableau's query pipeline. We're going to talk about what it is and why does it matter. And then we're going to look at some common scenarios. We're going to take a look at what's going on. We're going to look at why is this happening. And then even more importantly, how can you, we, what can we do about it, right? How can we fix it? How can we change that? All right, so now we walk into a restaurant. We're greeted by the wait staff. They seat us down. The waitress comes and says, can I take your order? So shout out time. What looks good on this menu? Okay, got seafood, got pizza. What's that? All right. Ribs. Okay, so pizza, right? You might want to go and get your pizza with pepperoni and sausage, maybe anchovies and pineapple, whatever you want. Maybe you're like myself and you gravitate towards the steak. Want to get it medium, maybe some rice pilaf, some broccoli, whatever it might be. Now, the great thing about going to a restaurant is, one, you can order the food and have it made however you want. Get whatever you want on your pizza. Have your entree, however you want. But the other thing that you can do, if you desire, is that you can actually adjust the order in which that food is delivered to you. So if you want to start off with your entree and then have your soup and finish with a salad, you can certainly do that, right? There's nothing that prevents you from doing that. Or maybe you want to start off with that wonderful cheesecake up there. Whoa, yeah, And then maybe you get a soup, your entree, and finish up with an appetizer, right? It's totally up to you. Yeah, there's a customary way of doing it, but there's no hard, fast rule that says you must order your food this way and have it delivered this way, right? The great thing about a restaurant is you can do it and have it delivered however you want. Now, on the opposite end of the spectrum, we have these types of mathematical calculations. Now, so the question is, shout out time, what is the answer? 12, 22, 27, 22? Or is it number 4? Yeah, I really don't care. All right, so why do I bring that up? Well, how many people remember good old Aunt Sally? All right? So please excuse my dear Aunt Sally. A way to help students remember how to do mathematical equations, right? Do everything in your parentheses first, then your exponents, multiplication and division left to right, addition and subtraction left to right. Now, you can't wake up one morning and say, hey, you know what? I really feel like doing subtraction first today, and that's what I'm going to do. I'm going to start off that way, right? You do, you're never going to get the right answer. You have to follow that order of operation. You have to do the way it's designed here. If you don't get the right answer. So the answer is, for everybody, 22. So you might say, okay, Kevin, why are we talking about food? And then why are you taxing our brains with a mathematical calculation? Well, it's all about the order of operations, right? There's that spectrum. Order your food and have it delivered however you want. Mathematical equations, you have to follow a strict order in order to get the right answer. So Tableau has an order of operations also. And knowing that, it's going to allow us to do some things maybe a little bit different. Maybe order our food or have our food delivered a little bit differently. Now, we do lean towards the more structured side of things. But as we go through this today, you'll see how you can understand and adjust things and where we're doing things. All right, so at the very top of the query pipeline, and we work from top down, we have extract filters, right? Pretty common. I'm going to reach into my data source. Maybe it has 20 years worth of data. I only want to look at or analyze the last 5. So I create an extract for that. All right, that's pretty straightforward. Next in the pipeline we run into is the data source filter. Common scenario might be that, okay, I have those 5 years of my extract. I only want to now focus on the last 3. I can do that. Or maybe I'm going to do row-level security. And so I can implement that as a data source filter, going against either a live data source or an extract. Okay, so those two things I've sort of segmented up top, right? They're in that light blue box. We're really not going to talk about those today because those have to operate in that order. You do your extract if you're doing one, and then you can do a data source filter if you're doing that, and you're good to go. But everything in that lower blue box, this is things where we can start to have some fun. We can start to maybe do some adjustments, start thinking about things a little bit different, how we're doing them. When do we want to do something? So the first thing we find in that blue box is a context filter. Now, by default, all filters in Tableau are independent in nature. So meaning that if I have a filter for cities, I'm going to filter that. If I have for products, I'm going to filter that. And when all my dimensional filters are done, I'm going to go and sort of mash them up together. And the intersection of all that and whatever drops out, that's my record set going forward. And those are all independently computed. But context filter says I can take some of those dimensional filters and put them in context, and everything else will use that context, will use whatever's been put into that contextual filter. So next down on the right-hand side, we have sort of things that happen in parallel. Sets, conditional filters, doing a top-in, computing a fixed level of detail calculation. Then we jump back into the pipeline. We have dimensional filters, where city equals something, state equals something, product, whatever it might be. Then back again, we have some things that operate or that work in parallel. We compute your include and exclude level of detail calculations, your simple aggregations, your min, your max, your sum, your average, those types of things. And this is where data blending is also done. How many people do data blending? Okay, so a few. Each time we get fewer and fewer because we've brought in just the last couple years the ability to do cross-data source joins. So it starts to remove the need or the necessity of a data blend. But data blends are still out there, they're still popular, and there's still a good use case for them, so we're going to talk about that. But that's where data blending happens in the pipeline. Next, we're going to have measure filters, where profit is greater than something, discount is less than something. Then once again, some things that happen in parallel. We compute the forecast and the clustering, and this is also where the computation of table calculations occur. Now that we have the table calculations, we can use those back in the pipeline and do a filter on them. And then finally, we have where we compute out all the trend lines, reference lines, and the pages. So we are going to come back and we are going to reference this many, many, many times in the next 45 minutes or so. So we'll come back and we'll look at what's happening, and then we'll look at how we can maybe adjust some things. So before we do that, we're going to have a shout-out time. Help me understand what these two things have in common. Now, that's the great state of Iowa, the breadbasket, if you will, of the United States, along with Kansas, Nebraska, and so forth, but that's Iowa. And then on the right-hand side is what you consumed last night and killed off a lot of your brain cells. Yeah, adult beverages. All right, so shout out. What do they have in common? Corn. What was that? Right here. Ethanol. Other ones? Anything? Okay, it could be drinking per capita. All right, so a lot of times we do say that, yeah, alcohol is made from grain, right? So that could be a good correlation. So let's just do some fun facts on Iowa. They have a lot of farmland, 30.5 million acres. That's larger than the state of Mississippi or Pennsylvania or Ohio. Anybody from Iowa? All right. Okay, so right here, do you live on a farm, grow up on a farm, or have ever visited a farm? Okay, so you're 94%, because 94% of everyone in Iowa has done one of those three things. Gentleman over here.
I worked for years, so I've
Been on farms, right? Okay. So the point is that Iowa is a very agricultural-driven economy and state, and most everybody in the state has either at least visited a farm, if not grown up on one. Number one in corn production for the last 150 years, and probably for the foreseeable future. 192 bushel of corn per acre versus the national average 168. When I was a kid, we were probably at 70 in Michigan. That's huge. That's a lot of corn. Average farm size of 350 plus acres. And then corn is found in lipstick, paper, plastic, tires, crayons, beer, and alcohol, but that is not the answer that I'm looking for. Yeah, so what it was, and it's almost what this gentleman said down here, but we are going to take a look at what our friends in Iowa are drinking. The correlation is just the data set that we happen to be using of adult beverages and the sales in Iowa. We'll take a look at things like, well, who's drinking Captain Morgan? Or maybe we'll look at and say, in Story County, what are they drinking? So in the next 45 minutes, we are going to answer these 4 questions and maybe a couple more. We're going to take a look at what are the top 10 products sold in each city. We're really going to focus just on Iowa City. Then we're going to take a look and say, all right, of those top 10 products in that city, they have to have a bottle price greater than $15. Then we're looking and see, how do I find the average number of bottles per person per county, back to your per capita. And then Joe's going to go and bring it home with, how do I look at the top 3 cities in each county and show the reference lines for overall average and county average. So that one's going to be a little bit more difficult, so we're going to pay attention to that. All right. I do need to put my professor glasses on. All right, so once again, we just to review real quick, This is the query pipeline. We're going to come back and reference this over and over and over. And with that, also, please, 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 do your survey at the end. We really do appreciate the feedback, good, bad, or indifferent. It allows us to adjust for next year and different sessions that we do. So please remember to do that. We'd appreciate it. Okay, our first question. What are the top 10 products in Iowa City? So this is the answer. We can see that we have Cinnamon Fireball Whiskey, we have Jameson, Jack Daniels, Hawkeye Vodka, folks from Iowa. Evidently, everybody in Iowa loves, it's like the second most popular alcohol there, home of the Hawkeyes in Iowa. And then also Grey Goose. So that sort of rounds out our top 5. And we can see the others. So that's our goal, right? We want to go and do that. So that should be pretty simple. All right, so first thing I want to do is what are our top 10 products based on the total sales. We'll look at total, and we'll look at product description. Let's go ahead and sort that. We'll flip it around, and let's filter our city just down to Iowa City. For these in the back, I'll zoom up real quick so you can see it. All right, so there we're just going to look at Iowa City. Now go ahead and bring the city in also in the viz. All right, so we're well on our way, right? We can see that we have our Fireball Cinnamon Whiskey, Jameson, Jack Daniels, Hawkeye Vodka, Grey Goose, et cetera, et cetera. But we want just the top 10. Okay, well, that's pretty easy. Let's grab our description. We'll bring it in, say top, by field. Right, so we just want to do our top 10 by total. Looks good. And we'll say OK. Let me go ahead and make it a little bit bigger. There we go. Fireball Cinnamon Whiskey, Jack Daniels, Hawkeye Vodka, Grey Goose. Something's wrong. Let's go back and look at that answer. Yeah, that answer shows Jameson as number 2. And we're showing Jack Daniels. We need Jameson in here. All right, so let's take a look at what's happening in the query pipeline. So first thing we're doing is we do our top N. We can see it described out there, our top 10 on the description by total. And once we've determined the top 10, then we said, okay, of the top 10, just filter it down for Iowa City. So it's a valid question that's being answered, but it's not the question we asked, right? We want, what are the top 10 for Iowa City? So we need to figure out a way of either moving my top N lower into the pipeline, or we need to figure out a way of taking my dimensional filter and moving it up higher in the pipeline, either equal to the top N or above the top N. So earlier when I went through the pipeline, I mentioned context filters, right? If I put something in context, then everything else below that in the pipeline will adhere to that, if you will, or use that result set. So let's try that. Let's see if we can move this dimensional filter and put it up into context, and if that'll solve our problem. So I'd come in here, Iowa City. We'll go ahead and put that into context. And sure enough, right? So now we do have our Jameson. We have our top 10 just for Iowa City. So let's look at what the query pipeline, what we did. All right, so we have our dimensional filter for Iowa City that we put into context. So now everything below that will utilize that filter, that record set that's been filtered. Make sense? Anybody, is that an aha moment for anybody? Yeah. That's very common. That's something that bit me early on. Okay, so let's move on and let's expand that now. Whoops, don't do that. Let's go right. So this is what we want. This is our end result. What are the top 10 products in each city, or in Iowa City in this example, with an average bottle price greater than $15? So we want top 10, but it has to have a bottle price greater than 15. Okay, so here's where we were with example 1. So we just need something that says greater than $15 a bottle. Okay, let's say bottle price, average, greater than 15. Okay, so we're just going to have our greater than $15. We'll say okay. And what happened? Now we're only seeing 7 records. Well, let's take a look at the pipeline. All right. So the pipeline says dimensional filter in context for Iowa City. We know that. That's good. We said, give us our top 10. So we're take Iowa City. Now we said, just give me the top 10 in Iowa City. So we have that. Now we're saying, of those, just give me everything that has a bottle price greater than $15. And there's only 7. So we get our result set has been reduced down to those 7 records. So once again, looking at the pipeline, we need to figure out a way, how can we move our top N either down, below our measure filter, or how can we move our measure filter up? So up here, I see that I have above my dimension filter, and even with top N, I have sets, conditional filters, and fixed level of detail. So I'm wondering if I can do a fixed level of detail and if that'll solve it. Let's give it a try. So I want to create a fixed level of detail for my average, we'll call it LOD, average bottle price. And we'll say we want this to be fixed at the city, at the description, and let's give it the average bottle price. All right. Quick response. How many people use level of detail calculations? You love them? Yeah. Yeah. I bet. I love fixed because you can actually fix and tell it what to do, and I want to tell it, I want to control. But this is what we're going to do. Fix it at the city and description and just give me the average bottle price. Okay, that sounds good. We'll say okay. So let me get rid of this one. Let's take our LOD that we just created. We'll use that as a filter. Average. Wrong one. Hang on. Level of detail. There we go. And we'll set that at 15. We'll say okay. Same answer. All right, let's take a look at the pipeline. All right, so here's an example, a fail-by example. We have our filter up there for Iowa City in context. Top N is being computed. The fixed level of detail calculation was calculated at the same point, but because we're using that as a measure filter, it gets pushed further down into the pipeline. So the point to this is, don't be afraid to try things, right? You try it, you're not always going to be successful, but you'll learn, right? It's a good learning experience. Okay, so we failed. That's okay. So now I need to figure out, is there a way that I can take that top N and push it down into the pipeline, push it further below the measure filter? Well, let's take a look at what we have. We have trend lines. Yeah, it's probably not going to do it. Reference lines, no. Pages, nope. Forecast, no. Clustering, probably not. Table calcs. Maybe I can do a table calc. Well, let's explore that. Let's see if we can use a table calc to help us out. So I'm going to take and put a table calc on my sum of my total. But let's look at what our options are. So quick table calc, let's see. We have running total, difference, percent of total, rank. Oops, you can't do that with, all right. So let's see once if rank will help us. So I do a rank, I get my 1 through 7. All right. Well, maybe I can put that as a filter and change it from 1 to 7 to 1 to 10. All right, that's going to get, I'm looking for top 10. Well, still nothing. Let me look at my bottle price, see what that is. So my average bottle price is greater than 15. All right, we can see that. But I still only have 7 records. Oh, I left my top in on my description. So let's go ahead and remove that. And so now I have my top 10, 10 through 1, or so we have 1 through 10. Let's make sure our bottle price is greater than 15. Yep. Okay, so let's take a look at the pipeline. All right, our dimensional filter in context, we can either use on the measure filter our level of detail or our regular standard average calculation. And then we did a quick table calculation using rank, and that gets pushed down further into the pipeline. So now we can get our top 10. And we could change that to a continuous. We could then have it be range, and we'd allow the end user to adjust it and so forth and so on. Make sense? All right. Okay, let's step it up a little bit. Third question. How do I find the average number of bottles sold per person per county? And then from there, what are the top 3 counties? And then finally, what about the percent of sales? So, in my data source, I do not have census data. But I have another data source with that. So let's see if we can utilize that. So let's see. I'm getting ahead of myself. So really what I want to do is bottle quantity. Let's put that on color. Set that to average. Yeah, let's throw that on label. All right, so this is just showing us the bottle quantity. We need it by person. As I mentioned, I have another data source that has that. So let's see if we can compute that as a per capita. So we'll call this average bottles per person. And we'll take and say sum our bottle quantity. And let's divide that by, I have my census data over here. I have my current population. So we'll bring that in. So now I'm doing a blend to another data source. And I'm connecting on the county as designated by the red link. And so I'm using sum of bottle quantity along with the census data. And so we'll say OK. We have our average bottles. Let's go ahead and put that on color. We'll flip our colors back. And let's put that also on the label. All right, so there we have our bottles sold per person. We can look at Polk County, 15.9 Anybody know what's in Polk County? The bars. Probably. State Capitol. This is where the laws get made. So they're consuming some alcohol to put all those wonderful laws in place. And how about Johnson County? University of Iowa, yeah. Iowa City. So once again, that sort of explains some things. So if I'm working for an alcohol, or I should say an adult beverage distribution company, I may be looking at areas down here in the southern part of Iowa, because there's over here we have 0.27 bottles per person in Fremont County. And that's hardly anything. And even over here in Wayne, 1.3. So we may look at this and say, we need to do more advertising. This is prime for additional sales, additional revenue, and those types of things. But if I change my hat, and let's say I work up at the state capitol, and I deal in health and human services, I may look at this data a little bit differently. So instead of, let me just go ahead and flip the colors around. And instead of seeing where high sales are good, high sales and consumption per person can be bad. So what stands out? Shout out time. Anybody see? Yeah. So we have that 22.26 bottles per person. And I'm like, that's huge. Because if you take and look the next closest over here in Blackhawk, they're 1.5 times more than that. If you compare it down to Fremont, that's like 80 times more. That's huge, right? I mean, that thing stands out. So if I'm working in the state capitol, I may be freaking out. I may be saying, you know what, we got an alcoholism problem going on up there in this county. We need to do something about this. Let's open up some clinics. Let's send some counselors. Well, let's take a look. So this is Dickinson County. So before we go and do that knee-jerk reaction and send a bunch of counselors up, let's just step away from the data a little bit, and let's look at Dickinson County. So shout-out time. What stands out when you look at Dickinson County? Okay, reservoir, lake, could be tourism, water, right? So I did a little bit more digging. Let's get a little bit more information about Dickinson. All right, 404 square miles. They are the smallest square miles of land. They're the smallest by land mass. They're the 5th smallest overall, but just from land, they're really small. 23 square miles of water, which is 6%, and then they have 15 parks and recreation areas. Now, I mentioned I'm from Michigan, and I also said, we not only do we have the 4 Great Lakes, we have 11,000 inland lakes. We have water everywhere. We have recreation areas everywhere. But I think the difference between Michigan and Iowa is that Iowa has cornfields, wheat fields, soybean fields. They don't have a lot of the lakes like we do. And I suspect that the hardworking individuals from Iowa probably go to Dickinson County and some others to vacation. Maybe we have some tourism. And so when I go, and I've asked my friends, when you go on vacation and you get, do you take your alcohol or your adult beverages with you? And usually the answer is no, right? Usually it's we get there, we get settled, then we figure out what we want to drink, then we go and we purchase it. So I suspect that that's similar to what's happening here in Dickinson County. The hardworking individuals go on vacation, they go and enjoy the recreation areas, they buy their adult beverages when they're there, and so can you say party, party, party? All right. So I suspect that there's not an alcoholism problem. I think it's probably skewed data just based on the population and the influx of people enjoying the lakes and other things Dickinson County has to offer. So we're going to just stand down on opening up some clinics, and we'll be good. Okay, back to the data. So now I want to find out what are the top 3 counties. Well, that should be pretty simple, right? We should be able to come in and say, all right, counties, let's throw it on filter. We'll do top, and we're going to do our top 3. And we're going to look at it by average bottles per person because that's the calculation we created. All right, we can see that over here, average bottles per person. So we should be able to find that here. Looking for our top 3 based on what's not there. Well, let's take a look at the pipeline and figure out what's going on. All right, we want to do a top in, but the problem is that we're using a blended calculation. And that blend hasn't happened yet until further down in the pipeline. Therefore, that calculation is not available for a top in. So we need to figure out again, how can we either move the blend up, can't be done, or how do we take our top in and push it below the blend? Well, we've seen that earlier, right? Maybe a table calculation will help us there. So we can come in and we'll say, all right, we'll take that calculation we've created, we'll throw it up in filter. We really don't care about this at this point because what we want to do is turn it into a table calculation, do a rank, and we'll say just do a top 3. And we probably want to look at it like a bar. All right, so let's take a look at the pipeline. So we have our blend happening, and then we're able to do a table calculation. So the point being on this exercise right there is that you can use or have table calculations on blended calculations. Okay. So our other question is, how can we compute the percent of sales? So we have our bottles, but I also want to know what is the percent of sales on that? Well, that should be pretty simple, right? We can just take total, put it on label, and turn that total into a table calculation and do percent of total. Let's go ahead and put my font just a little bit smaller. All right. So here we have it. And let's just focus up on Dickinson County. So Dickinson County is 1.31% of the overall sales done in Iowa. Okay, that's pretty good. What if I said I just want to see Dickinson County, we'll go with Polk County, and let's go with Johnson. And that's all I want to look at. So what happened? We went from 1.31% to 4.44%. So what's happening is it's calculating just based on the records that we kept, right? Our filtered values. Okay, well that's a good number to have, but I also want to maintain that overall number, the 1.31%, the overall sales for the entire state, and also have it calculate for just the counties that I select. So the question is, how can we do that? So let's go ahead, we'll remove that. All right. So we're doing this now. We have our dimensional filter, right, the ones that we select, just a few counties. We have our blend, and then we're just doing our percent of sales based on total, and that's good. But I want it to be fixed. I want it to maintain that number regardless of what we select. So what I need to do is figure out a way of how can I do that percent of total sales higher up in the pipeline before we do any kind of filtering. So we have fixed level of detail. Well, let's see if that'll do it for us. All right, so we'll call this LOD, percent of total. So I'm going to do my sum of my total. So wherever I happen to be, whatever dimensionality I'm looking at, in this case, county, and I want to divide that by the sum of a fixed value of the overall total sales. That. Okay, some total, oh, you know what, you got to have the right name in here. You think it's hard for you to see? It's hard here too. All right, so let's take a look at what that calculation looks like. All right, so we're doing a sum of the total. Once again, whatever dimensionality I happen to be at. Now that could also have been a fixed at the county level, but it's not as dynamic. So we're going to leave it this way. And then the other part is you have to have an aggregation on the other side, otherwise you get that nasty message. And then the sum is just a fixed level of detail calculation that says just give me the overall for the entire record set for total sales. All right, so we'll say okay. We'll take our LOD, percent of total sales. Let's throw it on label. Let's go ahead and change our format, the percent. Okay. So if we look at Dickinson County, we have 1.31% for both the overall and the value that's just going to be selected depending on what we choose. So let's see if that works. So I just grab these counties here, and I say, just keep only those. So we have 14.47% for just the counties that were selected. That's what our percent of sales are for just those counties. But we've also maintained the 1.31 for the overall sales. All right, let's look at the pipeline. Okay. So first thing we do is we do the fixed level of detail calculation. No filters applied or anything like that, so we get that overall number that then we can do our calculation based against. Then we go through and we pick out whatever counties we want, and then we had our blend. All right. So with that, I'm going to ask Joe to come up and take us home.
All right, I'll take us home. So my example is a couple of examples. One is the example of don't volunteer for a presentation unless you kind of know what you're in for, because this example, it took me a while to figure out. And so I'm going to take you through the final example and also take you through some of the tips and tricks that I had to kind of learn along the way to get to the solution. Kevin never clears his screen nicely for me, so I'll okay, let me get over to my question for you. All right. So what we're going to try to figure out here, and it looks like a reasonably simple question. I want to find the top 3 cities total in each county of consumption and show reference lines for the overall average and reference lines for the individual county average. And the trick here is we want the reference lines for the county averages to contain all of the cities within that county to get that county average, but we only want to show the top 3. And that's where it becomes a little tricky. So we'll walk through that a little bit slowly, but I only have this one example to show. I'll show you a couple of techniques along the way. So let me make sure I'm on the right data set. I think I am. Yep. So top 3 cities in each county with reference lines for the overall total and the individual county total. So we'll start just like we have earlier and just use our total consumption. And we wanted our counties. And let's flip that so we can see them. They're a little bit of this way. Polk County up on top, just like always. And our cities. And we'll sort that. So we've got a simple bar chart showing our top counties and our cities within each one of those counties. Relatively simple, straightforward. Now we want to show our reference lines. And reference lines are one of those things, as you use more and more Tableau, and as like Kevin and I go into more customers and see their dashboards, reference lines I think are one of the most underutilized aspects. They can really help kind of clean up dashboards and unclutter dashboards where you might want to put multiple bars or metrics out there, marks out there to show maybe quota and attainment or current period versus last period, and you have multiple bars. A lot of people, when you see really well done dashboards or visualizations, there's a lot of use of reference lines to eliminate kind of duplicate measures being out there side by side. So if you want to save space, you want to unclutter, using reference lines is a great way to do it. So reference lines are done, if you don't use them a lot, pretty straightforward. You can use them straight from the reference lines on the analytic tab, and when you pull them out, you get three options. One is it ultimately is kind of the scope of the calculation of your reference line. The first one is the total, which means the entire window of data that you're pulling back for your visualization, for your sheet. The next one is your pane, which if you think of a window of data, your pane is your first level dimensionality, how it's breaking it down. In this case, we're breaking it down by counties, and that's each individual county is a pane. Or you can use the cells, which is each individual mark, which doesn't apply all that often, at least in our case. So we'll drop it on table. And I'll just clean it up. I won't put the calculation or anything like that out there, but I'll make it nice and fat so we can see it. And we've got a reference line for our overall total. And our average in this case, our overall average, and we'll use this to validate some of our other techniques, is 961. So keep that in mind for our overall total. We also want a reference line for our average within each county. And again, just like I talked about before, our counties are dividing up our data by our panes. And we'll keep it clean and make it nice and big so we can see it. So we have 961 for our overall average. And for Polk County, we'll use Polk County as a reference. We have about 5.7 million. So you would think we're almost there, right? So the only thing we have to do is get our top 3 cities. So the first thing you might want to try to do, and I think Kevin showed where this can be a problem earlier, is use your top by a dimension filter and just show your top 3. Pretty straightforward. But look what happens. It's really the scope of that, right? So it's just taking our top 3 cities overall, Des Moines, Davenport, and Cedar Rapids. It's not taking into contents the individual, those panes of data. So let's see why that doesn't work. Well, the next thing we might want to try, and we'll reference back to the actual the chart that we had up there earlier to show why that doesn't work. The next thing we might want to do, like he did earlier, is use a rank. Rank functions, I think, I don't want to say underused, but they're very useful, especially when you want to sort things dynamically, when you want to use them in parameters to be able to take, if somebody wants you don't want to just show top 10, you want to show top 20, top 30, top 50, and add some interactivity to your data. Ranks are a great way to index your data and control it that way. So let's try a rank function. So a rank is actually a table calculation, so we'll grab it down here. I got some example calculations that I'm going to use. I didn't want to take the chance. There's no way I could actually type that thing out for you with 400 eyeballs staring at me. So pretty straightforward. Just doing a rank across the sum of the total. It's going to give us a number, an index number for each one of our counties, for each one of our cities. So we'll throw our rank up there in between county and city. And we're getting closer, right? But the scope of our rank is off, right? So we have 1 through 370 or 393, whatever it might be. It's not taking into account the individual counties. We want to break on the counties. But what you see is rank is a table calculation, probably one of your most useful table calculations, indicated by the little triangle up there. The nice thing about those is we have a table calculation, a real visual editor, which came out on May 10.3 or 10.5, which really helps. You can actually in real time see what it's actually calculating. Right now it's calculating the scope of that calculation is the entire table. If I want to change it to the pane, it'll react in real time so I can kind of see how it's doing that. And if I have multiple panes of data, of crosstabs. I can do pane and then a cross, and so I can be very specific about how it's calculating things, especially when you're trying to do percentage of total, within different dimensionality. It's really useful. So just by editing that table calculation, really slick. And so now you can use that rank function in a number of ways. I can use it in a parameter. I can use it in filters. In this case, we'll use it in a filter. We'll just rank and use that to calculate our top 3. Pretty straightforward. And we do that, and we check our numbers. Looks like we're home free. How often does this happen? You think you're good until you validate your numbers, right? So what's going on here? I got 1.4 million rather than, 960 something for overall average. Polk County was our reference at like 5.7 million, and I'm multiples of that now. So what has happened here? So we'll go back to our pipeline once again. In this pipeline, this is, if you, my query pipeline right here. This is in the help site. If you just Google query pipeline Tableau, this pops up. It should be pasted on your cube. I think most of the people that do these things every day have it up there because it'll trip you up a lot. So print this thing out. So what do we have? We're using our rank. The challenge here is we're starting pretty far down in the query pipeline to begin with, right? So we're using a rank, a measure filter. We're using our table calculation filter just below that. And not until we get all the way down to the very bottom are we getting our average lines for our overall average and our county average. And so what's happening is our rank is actually taking out applicable cities for us and it's calculating our averages incorrectly. So we have to do one of two things. Only thing we really can do is move our reference line calculations up higher in the query pipeline, right? And this is something Kevin did a couple of times, kind of seeing which is easier to move something down or move another one up, right? So our rank is actually working pretty well for us. We like that. But let's see if we can move our reference lines up higher. So what are our options to do that? We have sets and conditional filters, tops, ends, all those things, and I'll let it out of the bag. Your fixed level of detail here is what's going to help us, right? And I know a lot of people raise their hand and have a love-hate relationship, I think, like you said, with level of detail. I always think it's always funny how no one ever says I used a level of detail calculation. It's always an LOD came to the rescue, right? So I think an LOD will come to the rescue here again. But there are also, I think there was 14 or 15 separate sessions on LODs. So if you get a chance and if you're just starting your kind of Tableau journey, getting comfortable with them, and it takes a while. It takes a while for them to click. Once they click, incredibly useful to use. So be patient with them. You'll get there with them. Get back to me. So that's what we have to do. We have to move our reference line calculations up higher in the query pipeline. How do we do that? Well, our default reference lines aren't going to do it for us, right? How we use those from the analysis pane, not going to work. So let's just remove those, which before I did this presentation, I didn't know you could actually just do that. So that's kind of cool. So again, level of detail calculation. So let's take a look at an example level of detail calculation for our overall average. So again, it's a pretty straightforward calculation. Your first thing you're doing is specifying the scope, and then the aggregate, whether it be a sum or an average or something like that. So all we're really doing here is taking all of the counties and the cities, fixing it at that overall level, and taking the average. And the great thing, I don't know if Kevin mentioned it or not, the great thing about a fixed LOD, there's includes and excludes, but the fixed one is that it fixes that calculation at that granularity, regardless of the level of granularity on your viz. Right? So you can have lots of different mixed levels of granularity, averages at different levels, sums at different levels, percents of totals, and regardless of what you're showing on your viz or if your users drill down or do different things, this LOD will always capture that same level of granularity, which is why the fixed level of detail is very handy. So let's drag that out here, and I'm using a technique I actually learned from Kevin, is when you're stuck on a calculation, forget about how you want it to look. and just start throwing, and make sure you get your numbers right first. With Tableau, there are always ways to format it and get it working. It's infinitely flexible that way. So you're just throwing numbers out there to validate it. This is nothing like my data is going to look. So I have Polk County, my overall average, 961. So they're all the same, so that's my overall average. So I know that data is right. That calculation at least is right. I got my next one, I want my my average per county, which you'll see is a very familiar calculation, because I'm using really the same calculation I did for their overall total. I'm nesting it here. There's a couple of ways you could format it, but I'm nesting it here, and I'm just taking my overall total but fixing it at the county level. So I'm going to have a number that just represents, regardless of what's on my viz, it's going to represent my average per county. Okay? Something similar that Kevin did for the percent of total calculation. And I'll bring that out. And that gives me Polk County at 961,317. So I know I've got a couple of numbers correct. But now how do I turn these two things into reference lines? That's kind of my challenge now from a formatting perspective, and frankly, that's where I got stuck, right? So, yeah. If it would have, I'm sorry?
Overall equation would work without those extra fields in the scope of the county and city.
Would it have worked without the county and field in the scope?
No, because you're fixing it at that level. That's what you want to compute on, so you need to tell it at the county and at the city so that it'll compute correctly.
Yeah, much like Kevin had to add the description for the bottle to make sure that took all those into account. And with fixed level of details, you may have 3 or 4 dimensions in there. It's your collection of dimensionality that you want to calculate at that level. Really flexible though, but boy, it takes a while to click. Right. So good question. So what are we going to do here? We got our numbers right, but those just aren't. That's not what we want, how we want to show this stuff. So what actually comes to the rescue here is our measure values. How many people have used measure values before? Really kind of understand them. Good. Well, a few of it. It's a concept that it took me a while to get, but it really contains all of my measures that are available to me within this particular viz. So I can use my measure values and drag them up alongside my others. But the whole collection of measures are now available to me. I only need those 2. I only need my 2 fixed level of detail calculations. Then I can manipulate them on my viz. So I'll filter them out. I think I got them both. And now I have those 2 available to me. Now all I have to do is worry about formatting them and turning those into reference lines. So what I can do, now that I have these 2, and these are a collection of multiple measures, use my dual axis, and then I turn into dots. All right, that's not that helpful, but it's starting to look more like how my numbers you want them to be laid out. The nice thing about my measure values and in combination here with my dual axis is it gives me multiple marks. It gives me my independent marks that I can format. So now you'll see my marks card has expanded more than it did before, because I'm using both that combination, my measure values with my dual axis. My totals, they're all just circles. That's by default. I can turn my totals back into bar charts. That's got to be the worst default color ever. I've got to turn it back. So my circle, so that I have independent marks. So now I have my measure values marks card. I can turn those into lines. And maybe change the size of them a little bit so you can see them. Make them nice and fat. So now I have 961 for my overall average, and you can see that goes all the way down, and 5.7 million for Polk County. And what do you always forget to do when you do a dual axis? Exactly. Synchronize your axis. In this case, we can maybe remove our header just to make it a little nicer. So, what have we done? Go back over a couple steps. So we've taken that default reference line calculation that we just used from the analytics pane. And it didn't give us a lot of flexibility because it's the very lowest thing in the query pipeline. But we've taken that up using a level of detail calculation higher so we can fix those and then do whatever we want on our viz, and we know those two calculations will stay nice and fixed for us. Okay? So, like Kevin said, unlike ordering food at a restaurant, or probably a lot of other examples that are really flexible, Tableau, the order of operations, in most cases does matter, right? And if you don't remember, what was it? Please excuse my dear Aunt Sally. Right. If you don't remember that one, we got a little thing that might, pop culture might help remind you of that.
There's only one caveat. The guy who runs the place is a little temperamental, especially about the ordering procedure. He's secretly referred to as the soup Nazi.
Why? What happens if you don't order right?
He yells and you don't get your soup.
What?
Just follow the ordering procedure and you will be fine.
All right, let's go over that again.
All right. As you walk in the place, move immediately to your right.
Medium turkey chili.
Medium crab bisque.
I didn't get any bread.
Just forget it, let it go.
Excuse me, I think you forgot my bread.
Bread, $2 extra.
$2, but everyone in front of me got free bread.
You want bread?
Yes, please.
$3! Nothing for you!
So, kind of stretching the metaphor there, right? But maybe help you remember. So, a couple other things. Let me get back into just real quick. Just a couple of reminders. Let me get back over here. If you get a chance, and all these sessions were recorded. If you get a chance to go back out onto the TC18 site, it takes about a couple of weeks. If you're interested in learning some of the things about level of detail calculations, these were sessions that were repeated. There's probably one or two left this afternoon if you can catch them. But please, it's a great way to up your skills with Tableau. That's today's session. And like Kevin says, please, we really take this seriously. So please.
Please fill out the evaluation.
Yep.
We do appreciate it.
Thank you.
Thank you.